A linear inequality, this is a little different than a linear equation because we have inequality signs instead. Less than, greater than, less than or equal to, greater than or equal to. So let's say I have 3 minus 4x is greater than or equal to 12. So with the steps of solving linear inequalities, it's pretty much the same as solving for linear equations with one exception. With a little star. The one exception is that when we multiply or divide by a negative, then we reverse the inequality sign. Flip, reverse, however you want to think of it, reverse the inequality sign. Okay, so this is one where we're going to have to do that, because first I'll subtract 3, negative 4x is greater than or equal to 9. When I divide by negative 4 here, I need to change this from greater than or equal to less than or equal to. So x is now less than or equal to negative, let's write it as negative 2 1/4. Because now I'm going to write this on a number line. So x is less than or equal to negative 2 1/4. So let's throw down 0, negative 1, negative 2, negative 3. So less than means I'm going to go this way. So just a little bit past negative 2. I'm going to use a bracket and shade that in. So now if I want to show this with interval notation, then it's going to be go left to right, negative infinity, points, 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 until I hit negative 2 1/4 bracket, so that it shows that I'm including negative 2 1/4. It could be equal to that. So that example was where we just went in one direction. We went just to the left. So now let's look at if we have two kind of endpoints. I'm leaving a line right here. But let's say I have x minus 7 is greater than or equal to 4, and 3 parentheses x minus 10 is less than 15. So this word and here, notice we have two parts to the inequality combined with an and. This is called a conjunction usually. So it means that basically both have to be true. I'm going to write the word both over here too, because that helps to think about it when we write our final answer. This has to be true and this has to be true. They both have to be true. So let's work it out first. So I'm going to add 7 to both sides. X is greater than or equal to 11. And this one, if I distribute the 3, 30, 3x minus 30 is less than 15. Add the 30 over, 45. Divide by 3, x is less than 15. Notice that time I didn't have to reverse the sign, only when you're multiplying or dividing by negative. Okay, so I have x is greater than or equal to 11 and x is less than 15. So let's put this on a number line. 0 over here, I'm just going to kind of sketch in. Here's 11, here's 15. So x is greater than or equal to 11. So from 11, I'm not going to put on the line yet. From 11, I'm going to the right, greater, with a bracket. X is less than 15, so at 15, I have a parenthesis, and I'm going less, so to the left. So this is saying this has to be true, this line has to be true, and this one. So the only time they're both true is from 11 to 15. It's the only time they intersect. So right in here, they both work. So, and just like the endpoints on the individual lines, we need to take that into consideration. So bracket 11, everything in between until I hit 15, but I don't want to include 15 because right here, 15 is not included. So my answer would be bracket 11, comma 15 parenthesis, from 11 to 15, including 11, not 15. So that'd be my interval notation answer. Okay, let's do one more conjunction one. We're just going to start right off the bat with x is less than 5 and x is greater than or equal to 9. So we don't have to do any working it out. Let's just graph these. Again, 0, say 5, 9 would be about here. So x is less than 5. So less than 5, parenthesis, less, on to the left, and then x is greater than or equal to 9. So 9 bracket to the right, greater. So that, this is, see the word and, both have to be true. When is this one true and this one true? Never. They don't intersect anywhere. Okay, both, I didn't write that word yet, but intersect, where do they intersect? Where are they both true? And so there's nowhere that they both are true. There's nowhere that they intersect. So this would be no solution. There's nowhere where this is true and this is true. You know, if I pick like 4, 4 is less than 5, that's true, but 4 is not greater than 9. Same, neither are going to work here, something over here. This is going to be true, but not this. Okay, so those are the and ones, conjunctions. Now how about the or ones? Next would be or, which are disjunctions. Disjunction. So something like this. 2x is greater than or equal to 12, or x plus 6 is less than or equal to 1. So this is true or this is true, just one or the other. So not both, but one or the other. One or the other. Union, too, is another way. Instead of intersection, it's the union of this and this is going to be our answer. Okay, so on the first one, divide by 2, x is greater than or equal to 6, or x is less than or equal to negative 5. Let's see what that looks like. So x is greater than or equal to 6, brackets. I'm jumping ahead, putting it on the line. I think it'll be okay though. And then x is less than or equal to negative 5 over here, less than, so this way. So now, since it only has to be one or the other, this is okay. Here I have points, here it's not shaded. That means neither of these are gonna work. Any of the values in between here are not gonna work in either of these. But then over to the right, this part is gonna work. So anything shaded would be my answer. So from going left to right, negative infinity to negative 5, bracket, and then we use a symbol, the union symbol. Union, so the U-looking symbol, bracket 6 to infinity. So that would be all different values that work in one or the other. Okay, so last one. One more disjunction. X is greater than negative 4, or x is less than 0. Again, didn't have to solve anything in this one. I'm just jump right into seeing what happens. X is greater than negative 4, so that's going to be this way. X is less than 0, that's going to be this way. So notice, it doesn't really matter that there's a parenthesis here because of when I go 0 less, that's going to cover it up. So everything is shaded. So this actually would be negative infinity to infinity, all real numbers. Any value you pick is going to work in one or the other of those.